the people who are supposed to retire actually retire and not hire replacements for them, right? Usually what happens is the elder folks retire and new folks join the company and the cycle continues, right? Everyone moves through different stages in the company. But depending on the business that the customer is doing, this entire situation could be different, and businesses might want to freeze the hiring process, or they might also want to lay off certain individuals, right? Now, when you want to do that for a very small company where there is an individual, I would say relationship between the leaders, senior leadership, as well as the small, the different number of employees, the smaller number of employees, then it's very possible or very feasible for leadership to take a decision and make sure who goes away and who stays. But when it's a very large company and you want to have a very progressive mindset in the sense that you don't want to lay off someone or fire someone on the basis of their manager, right? Because human relationships can have different kinds of tandems, which you don't want to, which you don't want your business to suffer from. So you want a more data science approach or a machine learning focused approach where you want to predict the attrition of an employee. This attrition could be the company removing the employee resigning themselves, or the employee retiring. Does that make sense, everyone? Yes or no?
Yes.
Yeah. So that's the idea behind attrition. So we have this data set called the attrition.csv data set. I mean, you can easily get that from the Ivy's portal. We'll share this notebook and the entire content with you. I'd request everyone to keep your focus on the larger problem statement. We want to build a model, a machine learning model that can predict attrition. Okay. So age, a period of employee life measured by years of birth. So this is not the age of the employee within the company. This is the actual age of the employee. The departure of employees from the organization. This is what we want to predict. This is our output value. All of the others are our input value. Business travel. Did the employee travel on a business trip or not, right? Usually you will get to understand that associates don't usually travel for business, trips. Senior folks travel for business. Daily rate. Employee salary for the period is divided by the amount of calendar days in the period. So this is basically the idea. What is the daily salary you are giving to the employee? This is not a monthly thing, because there might be some employees who worked only for 6 months. There might be some employees who worked for a longer period of time. So to standardize the employee salary, we've divided it by the number of calendar days on their last, taken salary. And that is their daily rate. Department in which they are working, distance from home, how far the employee lives from the office location. And there are a lot of other variables which you can go through, right? The idea being that to make any kind of model, you will have to arrive at a situation where you have multiple input factors, these input features, which you consider will be very important or very useful in making the output prediction. For example, if you want to predict the price of a house, there'll be certain features in your mind which will actually tell you the price of the house, right? For example, what is the area of the house, square feet area? Then a very important factor is the locality, right? The location in which the house is being built. Then the number of floors, right? So if you take a higher floor in a building, then you have a much more higher price compared to if you take a lower floor, right? There is a floor based appreciation in the price of the property. Then number of bedrooms. So 2 BHK of 500 square feet and 3 BHK of 500 square feet may be priced differently. Number of bathrooms, number of amenities, right? All of those different aspects contribute to the price of the property, right? So what we've tried to do here is we've tried to derive, or we've tried to find out all the input parameters that we believe will somehow contribute to the attrition of the employee, right? I hope things are clear till here, everyone. Yes or no? Everyone online, just a quick yes, no? That would be great. Thank you. So Now let's start with first getting the data for ourselves. So we've imported all the libraries. If you've been a part with the Ivy team, you know all of these individual libraries. We discuss all of these libraries in much more depth. Pandas, NumPy, Matplotlib, Seaborn. The warnings is just a separate library to hide all the extensive warnings that do not bother the code, but they are more of a versioning issue. But all of these libraries we cover in a lot of depth at Ivy. So if you're just attending post your Ivy Python training, so you'd be good with that. If you're not associated with Ivy yet, these are all the machine learning libraries and data science libraries that we use regularly to process data, understand data, analyze data, visualize data, etc., etc. Okay. So let's read this data set, the employee attrition.csv, right? Now, before we do any kind of model building, it is very, very essential that we look at what the data is. We try to figure out, are there any issues with the data? For example, if you have a lot of duplicates in the data, what do you think? Should it impact the machine learning model or not? If you have a lot of duplicates in the data, should it impact the machine learning model or not? So for everyone's understanding, duplicate data has no effect on the model. Okay. It does not have a positive impact. It does not have a negative impact. It actually has no impact. The only impact it will have is it will take a larger time to process the data, to train the model, because the data is repetitive. The model will not learn anything bad. The model will not learn anything good. It will not learn anything from the same data. Why is that? Just think of a machine learning model like a student, right? If you give a student 10 same practice problems, for example, I am trying to teach a student how to add two numbers, right? If I want to teach a student how to add two numbers, I should give them different practice problems. For example, 35 plus 25, right? 23 plus 72, etc., etc. But what if I give the student the same problem statement again and again, right? If I give the student the same practice set again and again, it does not increase the learning of the student. Is that making sense to all of you? Yes or no? Yeah. So duplicate data dropping. Let's say there are missing values in the data, right? There are certain values that have not been recorded. So we need to handle them because machine learning models cannot work with not existing data. They don't know how to derive meaning from missing data, right? We also need to check the shape and size of the data set, the different columns, right? Do they make sense or not? Data type verification, etc., etc. So let's start with a quick basic data exploration. We start with the head of the data set, which is the first 5 rows of the data set. We see that we have the age, attrition, business travel, daily rate, department, distance from home, education, etc., etc. All the features that we noted down here, right? All of these features are there in the data set. From all of these different features, what do we really want to predict? We want to predict attrition. All the others will act as an input to my data set. Okay. This is just a small pandas code to be able to view all the columns, because here we were limited to a certain number of columns. If I would have restarted the kernel, it would have made more sense. Give me a second. So the idea is, if you would have started like this, in this particular case, you can see you would have not had access to all the columns. There would have been these 3 dots that actually indicate that there are a lot of columns in between that you can't view. To solve that problem, we have this small piece of code that increases the number of maximum columns to infinity. So the number of columns that you will be able to see will be the number of columns in the data frame. So if you now check this out, you don't have that dotted section anymore. Can you see here? There was after employee number and between relationship satisfaction, there were these 3 dots. Now you can see employee number is here, the same column, but then we have the actual columns in between, right? We don't have the 3 dots. Now the data.info, this is also an interesting measure because this actually gives us a lot of information about our data set. The first thing it tells us is the number of columns in our data set. So there are 35 columns in my data set. It also tells me the number of rows. So 1470 entries, that means 1470 employees data exists here with 35 total features where 34 is input and 1 is the output feature. For each feature, I actually get to see the non-null count. Now, non-null count can actually be treated as a proxy to understand missing data. If my total number of rows is 1470 and age has 1470 non-null, that basically means that there is no missing data in this particular case. If any of these values would have been less than 1470, this would have indicated that there are missing values in my data. To give you a quick example, let me artificially add that in the data. Suppose I add a missing value in the age column, right? What I have done is from my previous data, I have now actually introduced a null value. Originally, there was no null value. Originally, the value was 41. Now I have introduced artificially a null value. If I check the information now, can you see the number reduced by 1 unit from 1470 to 1469? I hope everyone's clear with that. Yes or no? Yeah. So let's just go back and set the thing up back to what it was. Okay. So we saw that there are no missing values, 1470 rows, 35 columns, right? For each of the columns, we have the data type. Now, machine learning models cannot work with object data type. By object data type, I mean string-based data type or textual data. Machines can only process numbers. They can do addition, multiplication, subtraction, division, etc. But they can only do those on numbers. So for all the object-based or textual data, we will have to do some kind of processing, which we will see is called label encoding, right? So business travel column needs to be modified. Okay. Yes, Shomadeep, the correct, like you've articulated it well. We need to convert the categorical data, which is textual data, into numerical data. Another function that pandas gives you is a very interesting function, the dot describe, which gives you descriptive statistics. Descriptive statistics is very useful because it gives you a very nice overall picture of your data set. For example, if I have this data set and I want to know the average age of my employees, how do I do that? I might have to first get the data frame, select the age column, and then do a dot mean, which would give me the average age of my employees, right? But if I want to find the average measure for a lot of different columns, I'll have to write the code again and again. Now that creates kind of a repetitive action. And those are the cases that are solved by the descriptive statistics section, the dot describe method, where you can see for all the numerical values, you have the mean value. So age has 36.92 years. Daily rate is 802. So on an average, my employees earn 802 per day. On an average, my employees live 9.19 kilometers from the office, right? Distance from home, I mean, that's the distance between home and office. Their education ranking is 2.91. Now I can actually go and look at what education means here. In education, 1 means below college, 2 means college, 3 means bachelor, 4 means master's, 5 means doctor, right? So I can actually define that, right? So 2.91, that means most of my employees are between, I mean, 2.91 would actually be between 2 and 3. So you can see 2 means college, and 3 means bachelor. So most of my employees are bachelorettes. Okay. I mean, they've done some kind of bachelor, either of engineering or commerce, etc. Great. So I can get this entire descriptive statistical analysis in just one single line of code. I can look at the average, I can look at the standard deviation, the minimum value, the maximum value, and all the percentiles. If you're not clear about percentiles, we have an entire statistical course where we discuss a lot more in detail, but the idea being these are different portions of your data set. So if you sort your entire data set starting from minimum to maximum, 25 percentile actually means 25% of your data will be less than this particular value, right? And so for 50th percentile, which is also called the median, that means it divides, this particular value divides your entire data into two parts. Okay. One part is less than 50%, the other is greater than 50%. Okay. And we usually write all the observations about the data set. Now, these observations could be something that drive the analysis. That means it might impact machine learning, or this is just a learning for people who are working on the project. We check the duplicates. There are no duplicates in our data set, so we are good. The duplicated data and the dropped duplicates data both have the count, same count. So there's nothing that we need to drop. We're also checking the null values. You can see there are no null values. All the values are 0, 0, 0, 0. Coming to the target variable. If you look at the target variable, there are 200, close to 200, 220 or 210 people who have the category as attrition. So these folks were removed from the company. Either they resigned, or they retired, or they were laid off, right? Or fired from the company. But these were the folks that had the attrition, that faced the attrition. And the rest of the group, out of the 1470, if you remove the 220 approximately, the rest of the people, the rest of the folks are actually the people who are still working with the company. Okay. Now, a quick problem that you will analyze here is the high imbalance of these two categories. One category is extremely frequent, large in number, large in count. The other is very small in count. Now, what's the problem? What happens when you have an imbalanced data set? So, imbalanced data set creates imbalanced learning. Take, for example, I'm taking an extreme example, but I think that will add a lot more sense. Suppose you are trying to predict cancer, or you are trying to predict fraud, right? Now, these activities that I'm trying to predict are actually extremes, right? They are very infrequent. Am I correct? Guys online, everyone who's part of the webinar. These are very infrequent, right? Not a lot of people have cancer, thankfully. Not a lot of transactions lead to fraud. Yes or no? Yeah. The problem is, if you train a machine learning model to predict cancer and it learns something weird, what is that weird learning? It can predict every case as no cancer and be 99% accurate. Does that make sense? Yes, Shomadip will be doing those things. But does everyone understand this example? If I predict that nobody in the world has cancer, I'll still be 99% right, because 99% of people in the world do not have cancer, right? The same thing for a fraud. Most of the transactions that happen are not fraudulent. So if I predict every transaction as non-fraudulent, I will be 99.9% correct, but that does not solve my problem. Right? So imbalanced data has this problem of imbalanced learning. If you have imbalanced data, your model learns and kind of fools you into giving you a higher accuracy while not learning the true potential or true pattern in the data. Okay. Right. So these are certain quick exploratory data analysis charts that we usually look at. We are looking at attrition with respect to department. So you can see sales has low attrition, right? R&D has comparatively lower attrition. Human resources comparatively has higher attrition. Can you notice why? We are not looking at the absolute numbers of attrition. We are looking at relative attrition. That means, think about it. If there are 100 members and 40 resign, so what is the resignation percentage? 40%? Am I clear, everyone? Yes or no? Hundred members, 40 resign. What is the resignation percentage? 40%? Yeah. Now imagine there are 1,000 members and again 40 resign. Now what is the resignation percentage? %, right? The idea being that the absolute number of resignations cannot be used to compare these two situations, right? That is why we need a relative approach, and that is provided by resignation percentage. Okay. So we can look at attrition with respect to department. We can look at attrition with respect to education field. We can look at attrition with respect to job role, right? And we can do that for all particular analysis. When you look at this chart, gender with respect to attrition, do you think there is any kind of gender discrimination in the company? What do you guys think? Is there any gender discrimination in the company? Yeah. So we won't get a complete picture if we look at it like this. Let's try something different. Let's go for the gender column. Let's try a method called the value counts. This actually gives the different counts of males and females. Now, this is also not useful because this is only going to give me male value and female value. What I really want is male attrition, no attrition, female attrition, no attrition. So I will use a function called group by. We discussed these things in a lot more depth, but just to consider the idea, we are grouping by gender and we are trying to aggregate something else. What is it that we are trying to aggregate? We are trying to aggregate attrition, right? So let's check the data of attrition. These are attrition data, right? I will need to convert the two things. So basically, I'll need to have what was the attrition. Let's say I'll just quickly do something else. Attrition. Let's say I add it here. I'm grouping by gender and attrition. And I'm going to find out the count of this. A lot of these things are taught in the sessions, but I'll just quickly show you guys how we do this analysis. Now look at this. Does this give a better view? All of you, does this give a better view? Yeah. So what we are doing is like if you are a female, were you removed from the company or not, right? If you're a male, were you removed from a company or not? Now what you can do is for the attrition cases like yes, right? We can do this programmatically and just quickly showing how we can detect if there was any kind of discrimination or not. You can see there was a 14.8% attrition in females. On the other hand, for males, we could quickly check 732 plus 150. There was a 17.00% attrition in males. Now, is that a significant difference to claim discrimination? Obviously, no. Because when we have a data of such smaller size, just 1,400 employees, a 3% difference would not count as a significant difference, right? So idea being you can do all those kinds of analysis if you just look at the data appropriately. I will have to drop the additional column that I created. And that's done. Right? So for each of the charts we generate, we have some observations, we do some analysis. Now, do not skip this part. If you skip the analysis part, what you're practically doing is you are throwing some data to a model, to an algorithm, and asking it to learn from the data. Now, that's very risky if you are not sure about how that data impacts the model. For example, I'll just quickly give you an interesting idea. If you want to predict the sales that Flipkart will have in the next big billion days, what factors are you looking for? What factors or features do you want your model to consider? Go ahead. I want to hear some answers from everyone. What factors do you want your model to consider? What do you think will be relevant for us to predict the sales that Flipkart will make in the next big billion day offer? Just put whatever thoughts come to mind, just pen them down on the chat box. The prices, the products. Right? The discounts are willing to offer, the people purchasing, gender may not be the best one, Astha, but yeah, it could have an impact. Will country have an impact? Will country as a column have an impact? Yes or no? Guys, we are talking about Flipkart. Does Flipkart sell globally? No. Flipkart only sells in India. So the country column will have just one single value constant throughout the data frame, and that is India. I hope that makes sense, everyone. Which is why it is meaningless to consider that column, right? And this is why you need to do analysis on the data. Unless and until you analyze the data, you might be making such blunders that don't add any value to the machine learning model, are just taking more of your computation time, your database storage, and all the other cost effective factors, right? You can efficiently reduce your cost by doing good analysis and making sure only quality features are provided to the machine learning model for learning the relationship. Okay. So let's look at the features that are already in numbers, right? These features are already in numbers: the education, environmental satisfaction, job involvement, job satisfaction, performance rating. These are already numbers, so we are happy with them, right? We don't need to make any changes here. But then these are factors that are non-numeric, right? I mean, there are certain factors that you can directly do categorical encoding. So just think about it. There's two types of categorical data. Two types of categorical data. What are those two types of categorical data? One is called ordinal. The other is called nominal, right? What is ordinal data? Data that has order. By that I mean, if you consider a value like education, right? If you consider a value like education, or let's say let's say performance rating, you know that a performance rating of 4 is better than a performance rating of 3. Yes or no? We know that a performance rating of 4 is better than performance rating of 3. What I mean by that is, if customer gives data like good, better, best, I can directly assign numbers like 1, 2, and 3, because I know that better is more important to me than good. Best is more important to me than better. So that is why there is an order in the categorical data. On the other hand, nominal could be simply colors, right? Like red, green, blue. These are basically subjective textual data, subjective categorical data with no particularly defined order. Make sense? Right? So in cases where our data is already in numeric form and it makes sense, we should be fine with it, right? Just to visualize, you can see below college was given a number 1, which is appropriate. College was given a number 2, bachelor was given 3, master was given 4, doctorate was given 5. So this is an appropriate order for education, right? For visualization, we can't use 1, 2, 3, 4, 5. So we've attached additional textual data so you can visualize it. But you can also look at attrition with respect to education, right? After all of these things that we have done, we want to do some encoding. What is that encoding? Now, obviously, the machine learning model will not predict yes or no, right? Just like machines don't understand text. Similarly, machines can't predict text. Just like machines don't understand text, similarly, machines can't predict text as well. So we need to encode textual data in appropriate format for the machine to learn from it and predict it. That is what we are doing here. We are replacing the no values in the attrition column with 0 and yes values with 1. Right? For a lot of other columns where we had categorical data, for example, gender, for example, overtime, we are converting them into numbers because they have some kind of order. And usually binary variables we can encode into any value. For example, the male 0 and female 1 does not have a specific order. Male could have been 1, female could have been 0. They will both act the same way for the model. If it is a binary variable that can have only 2 options, both the variables could either be 0 or 1, and that does not change anything about the modeling process. Okay. Now, coming to encoding categorical values which have more than 2 values, right? For example, business travel. If you remember, when we were looking at business travel had travel rarely, travel frequently. Can we look at number of unique values that business travel had? Business travel dot value counts. Can you see there were 3 possible values for business travel? The same for department. We have 3 different possibilities of department. Let's say job role. We have so many different job roles available. In this particular case, we cannot map them directly. Because can you differentiate which is more important to a company, the research scientist or the manager or the research director or the human resources or the manufacturing director or the healthcare representative? We cannot define and decide a number or numerical representation of these. That is why we do something called as label encoding. What it largely does is it converts it into numerical columns where originally when this particular option was available, it becomes 1. Wherever this option was not available, it becomes 0. So to quickly show you label encoding and what it does, right? Right? If you had the food name apple, chicken, and broccoli, here that you can see, apple, chicken, and broccoli, we actually created 3 columns instead of 1. The food name column, we actually created 3 columns. Wherever there was apple, we put a 1 and all the others became 0. So 1 shows the existence of the apple category, 0 shows the inexistence of chicken, and 0 shows the inexistence of broccoli. Similarly, in broccoli, which is the 3rd row, you can see there is an existence representation in broccoli and 0 and 0, which shows inexistence of apple and chicken. So that's largely what this is, right? VS Rishi, we are creating dummy variables. That's a more technical term. I didn't want to touch upon that, but yeah, if you know, you know. Okay, now let's quickly check. I see some issue in the data. Why is it nan? Let me just quickly go back and run this. So to show a lot of examples, I might have changed the code that would have caused some issue. Yeah, now the gender column is fixed and we have this label encoding. And finally, we have our data where you can see now there's only numbers, right? There's this one column where I see yes and no over 18, right? I can actually write a piece of code quickly, which will be over 18, where I will set yes to 1 and no to 0. And now you can see I have no more categorical data. I can actually quickly check this as well. I can do a data.info and try to validate if everything is an integer 64. And you can see they are all integers now. So I'm perfectly set up to train my machine learning model because I only have numbers now. So there is a very simple template of machine learning application today. Although machine learning has become very easy, if you forget any single part of this entire pipeline of this template, you might completely screw the model. Okay, so let's check this out here. We first split the data into input and output. These are my input features for X. This is my output feature Y. Okay, I split my data into 2 parts. Now, because we had a sampling issue, we had an imbalanced data set, we want to resample. Okay, so I want quickly everyone to take a minute and think about this. Write your answers in the comment section as well as in the chat. Should we oversample the minority class or should we undersample the majority class? What do I mean by that? Suppose there are 2 outputs, 2 possible outputs, right? One output is attrition. The other is no attrition. Where is the imbalance in the data? Attrition, let's say, is 10% of the data. No attrition let's say, is 90% of the data. Now, to balance this data, what can we do? We can increase 10% to 90%, which is called oversampling, or we can reduce 90% to 10%, which is called undersampling, right? So I want everyone to take 1 minute and think about the possible issues you can have with both of these, oversampling and undersampling. And in the chat, mention your choice. Do you want to choose oversampling or do you want to choose undersampling? I'll be back in a minute. What do you guys think? Should we oversample or undersample? Oversampling? Yes. So guys, the idea being, we can choose oversampling when we have smaller data set. Why? Because we don't want to lose the information we already have. And we can go for undersampling when we have a lot of data, because we can afford to lose some data. So should we oversample or undersample actually depends on the size of the data we have. In this particular case, the data set is very small. That is why we cannot do undersampling. That is why we are going to use a library called the ImbLearn, which stands for imbalanced learning. And we are going to use its oversampling submodule to get the random oversampler. And we are going to oversample the previous class, which was the attrition class, which originally had a count of 237. We are going to oversample it and duplicate it to 1233 cases. What this will actually do for us is, it is going to make sure that we now have a balanced data set, which you can see 1233 to 1233. This is a balanced data set. After balancing the data set, we are going to do the training testing split. Now, obviously, if I, just to give you guys a logic, if I give 10 questions during practice and give you the answers to it eventually, I cannot ask any one of those 10 questions in the exam. I can't do that, right? Because if I ask you the same questions in the exam that I actually taught you in class, you could easily cheat and you could get away with not having learned the actual pattern. That is why we do a training and testing split, so that our training data is what the model learns from, and testing data is where we really analyze the performance of the model. We genuinely analyze if the model has learned something or it is just faking by copying and pasting. I hope I am clear, everyone. Yeah. Oh, Shramadip, oversampling of minority will lead to a little increase in bias. Yes, it will, but there is no other way, right? Rather than losing data off by undersampling, we'd rather include some bias. Okay, and bias obviously towards duplicated data, so that will not change the model by a very significant margin. It will be very minor. Okay. Now comes the final part. Once we have our training and testing split completed, we are now going to implement the logistic regression model. Now, the logistic regression model is a classification model, although it says logistic regression because it has a component of regression, but it is actually a classification model. First, we build a linear regression model, and to this linear regression model, we apply a logit function. Logit function is also called a sigmoid function. What this function does is it takes a value and returns an output between 0 and 1. This output between 0 and 1 actually represents the probability of a particular output. For example, if I predict attrition with probability equals to 0.2, you can easily say that there will be no attrition. Yes or no? If I predict attrition with probability equals to 0.85, then you can easily say that there will be attrition. So the probability value that I have, which lies between 0 and 1, actually gives me the output prediction. And that is achieved by using the logistic regression model. Obviously, we are not going to go into the math of logistic regression. In the actual Python sessions and machine learning and advanced machine learning sessions, we do a lot of discussion on the maths behind it. But for now, we can definitely have just the logistic regression model. So we import the logistic regression model from the scikit-learn library. We have certain metrics that help us understand the performance of an imbalanced data set. We fit the data on our logistic regression model. Remember, we fit only the training data, not the testing data, only the training data. And then we predict on the testing data. When we predict on the testing data, this is data that the model has never seen. So whatever accuracy you get on the testing data set, that is considered to be a very close real accuracy of the model. And you can see we've gotten a 64% accuracy in this model, right? And although that's not a very good accuracy, but that's still decent and helps us understand what this small amount of data can help us achieve. To further validate the model's performance, we actually do something called as confusion matrix. Now, the confusion matrix is a very interesting metric in scikit-learn because it gives you a very in-depth idea of the model performance. Yes, Rishi, we can use grid search optimization, although not for logistic regression, but we can do it definitely for random forest classifier, or let's say a decision tree classifier, or add a boost or XGB, right? The purpose of this particular session was to get you guys an understanding of attrition models in general, but definitely you can try all the different classification models. You can hyper tune them to be the best possible case. You can also use different kinds of, like you said, sampling mechanisms, right? So there are a lot of imbalance handling solutions. There is SMOT, there is Addison, you have undersampling, oversampling, you have isolation sampling, etc., right? So that definitely is a part of another conversation some other time. But yeah, coming back to confusion matrices. Now think of it from a logical standpoint. What are the possible options? The possible options are yes attrition, no attrition, right? And what would be the possible predictions? Yes attrition predicted, no attrition not predicted. So this finally gives us 4 total prediction possibilities. What are the prediction possibilities? Actual value, predicted value. So look at it from this angle. The actual value was yes, and I predicted yes. So this is a right prediction, correct prediction. The actual value was yes, and I predicted no. So this is a wrong prediction. Actual value was no, and I predicted yes. Actual value was no, and I predicted no. So this is my right prediction, and these are going to be my wrong predictions. Am I clear, everyone? Yes or no? These two would be my wrong predictions, and these two would be my right predictions, right? This one is called true positive. What that means is I said positive prediction and it was a correct prediction. So this is true positive. This one is going to be called false negative. Why? Because I predicted negative and the prediction was wrong. So it is a false prediction. Similarly, this is false positive and this is true negative. So the confusion matrix actually represents these four values and gives us a very in-depth idea of how the model is performing. You can see expected value is the actual value. So no attrition, attrition. Predicted value is the prediction made by the model. So no attrition, attrition. So there were 169 cases where the actual data said there was attrition and the model said yes, attrition. And there were 149 cases where the actual data said no attrition and the model said attrition. So these two are my good positive cases. I want to maximize them. On the other hand, these two cases are my bad conditions. I want to minimize them. I don't want the prediction to be 1 where the actual value was 0. I don't want the prediction to be 0 when the actual value was 1. So I want to reduce these two, false positive and false negative, and I want to increase these two, true positive and true negative. Right? So this is how a confusion matrix gives a very in-depth view of how the model is performing. On the right hand side, you see something called as an AUC ROC score or an AUC curve, which is area under the curve. It actually represents if the model has honestly, genuinely learned the difference between the two cases or not. If the model would have not learned the difference, this would have been a straight line like this. And if the model would have been performing really well, it would have been a rectangular line like this. Right now, it represents that, yes, the model learned with a 64% accuracy, which is fine. Ideally, what we want for this particular chart to show is something like this. This is the best situation, and this is the worst situation, right? Better models would be something like this or something like this, right? But these models are basically going to tell us if we've really understood the two different classes, attrition and no attrition. Okay, so great, guys. That was the end of today's webinar session. I hope you all enjoyed it and you all learned something that you previously did not know, at least for the analysis part, the machine learning idea, the core logic. Now, obviously, it's very difficult to cover a project in 1 hour. Definitely, we will do a lot of other things. In actual classes, these are like 4 hours, 5-hour sessions where we discuss everything in a lot of detail. Some accuracy would tell regarding overfitting and underfitting. Yeah, so Rishi, if a student has generally learned something or not, I can get to know that by looking at his practice test scores and his examination scores. The idea being, if you really perform well, you will perform well in both cases. So if you have learned the concept, your performance will be consistent, right? And if you have cheated somehow, your performances will vary. That is how we actually check upon overfitting and underfitting. When you are overfitting, you will perform really well in training, but you will perform very differently. In fact, ideally in a very bad way in testing. So that would be the case of overfitting. For underfitting, what you will have is you will have an overall less accuracy in general. Okay, so there are many strategies to improve the accuracy, obviously hyperparameter tuning, trying different models and different approaches. This is just a larger context of how we apply machine learning for employee attrition prediction. Okay, so I hope you guys had a great time. definitely connect with the Ivy team if you're looking forward to doing a completely comprehensive course in machine learning, Python, data science, and AI. And I hope to see you guys sometime in class soon. Have a nice day. Thanks everyone. Bye.